Hey guys, we have finished with shapes, which means we're moving on to something else, Lewis structures. And also, I've discovered that Google Slides allows you to have this pointer tool. I'm going to have a lot of fun with this. So, this picture is really cool. It's got nothing to do with what we're learning about, but it's just really cool. This was the first ever picture taken a couple years ago of a single atom. So what they did, they got lots of lasers, shined it right there, and the atom reflected or absorbed and then reflected some of the light, and really powerful cameras detected it. So this is the first ever picture of a single atom that we've managed to take. That dot right in the middle is the atom. Cool. You should know this, but this is some background knowledge. Valence electrons, these are electrons which actually do the chemistry of an atom. These core electrons don't do much chemistry. Valence electrons are found in the valence electron shell of an atom, so this is your valence electron right here. And of course, sodium. Sodium is element number 11. It's got 11 electrons. 2 are in its inner shell, 8 are in its second shell, meaning that 1 valence electron is in its outermost shell. And this single electron is what does the chemistry. In ionic bonds, sodium will donate this to another atom, lose it, and gain a full outer shell to become stable. So, this is a chemist called Gilbert Lewis, certified badass, and in 1916 he came up with a new idea of how atoms bond with each other. This is your covalent bond. Atoms shared electrons between each other to form a covalent bond, and he also said only the valence electrons can be shared. None of the inner electrons can be shared. Atoms are most stable with 8 electrons in their valence outer shell, and he called this the octet rule. I've asked you to Google the octet rule in the past, and they're most stable. A lot of you are writing atoms want to have 8 electrons. Well, atoms are very, very tiny, and they don't want anything. Everything in chemistry is governed by what is most stable. Because if it's less stable, it's going to react. If it's stable, it's not going to react. So if it's stable, we can view it. And so we view most things as being stable, and they're stable with 8 electrons. And electrons are also found in pairs. These are two very important rules. Okay? I actually want you to write these rules down because they're so important. Electrons are found in pairs, and they're most stable with 8 electrons in their valence shell, and this is the octet rule. So if we look at this, carbon normally has only 4 valence electrons, but by bonding with 4 hydrogens, it can share the hydrogen's electrons in these electron pairs, or bonds. This represents a bond, and now carbon has got 8 electrons around it. Lewis dot structures of an atom only includes the valence electrons, and ignores all the core electrons. Sodium has 1 valence electron, so the Lewis dot structure for sodium is this, Na dot. We're ignoring all the inner electrons and just focusing on the outer electron. Chlorine has 7 valence electrons, and its electron configuration is 287, which adds up to 17, because chlorine is at element number 17. And so as you can see, it's got 7 dots around the outside of it, because it has 7 valence electrons. What this means is sodium can donate its electron to chlorine. Sodium will gain a positive charge, chlorine will gain a negative charge, and it'll make sodium chloride, that classic salt that we're familiar with. We draw these in a special way due to how electrons pair up. So we start by placing the electrons one by one around the outside of the atom. It can be clockwise, it can be anti-clockwise, doesn't really matter, as long as they're all separate to start off with, like this. Then, because electrons pair up, we start pairing them up. And so nitrogen, it's element number 7. It's got 2 core electrons and 5 valence electrons. These 2 are paired up, so they're fine, but it's got 3 unpaired electrons, meaning it needs to form 3 bonds to get 8. So nitrogen often forms 3 bonds, and it pretty much only forms 3 bonds in chemistry. Most common one is NH3, so nitrogen bonding to 3 hydrogens to make ammonia. Nice. So we can get two nitrogen atoms, put them together, and then make a triple bond between them with these two lone electrons on the ends of each nitrogen atom. These single electrons pair up with these single electrons and form a triple bond. This is nitrogen gas N2, and it's the most common type of gas in our air. This is also ammonia. You have the single bond, you have the single electron nitrogen up here. We call these lone pairs. You have the lone pairs of electrons up here, and it's making three bonds to hydrogen. This is a complicated molecule. I'm pretty sure this is caffeine. And again, you see nitrogen only forming three bonds in each case. Here we have a double bond and a single bond. Okay? Also note oxygen. Oxygen only forms two bonds. Oxygen only forms two bonds, and carbon can form four. So, your task now, I'll get you to this if we're in class, but we're not in class. Draw the Lewis electron dot diagrams and write the electron configurations for the following atoms. So let's have a look at carbon. If I can do this. Okay. So carbon, see? And it's got, let's increase the width of that. It's got 6 electrons, 2 core electrons. So its electron configuration is 2. Please make this work. 2, 4. It's going to be a bit of an issue. I don't like this group at all. 4. And then it's got, I'll use these little dots. It's got 4 electrons on the outside of it. Why is that? Okay, so this is what it would look like. Not great drawing. But you can see that carbon's got 4 electrons on the outside of it now. And if we go back to here, that's nitrogen with 5. Okay, so carbon will be carbon, just missing this one. Okay. And obviously neon is a noble gas, so it has all 8 electrons around the outside of it. See? Neon's got all 8 because it's a noble gas configuration. We can look at this and see how many bonds atoms usually form. To work this out, we just look at the number of single electrons around the outside of them. So neon has got no single electrons, so neon doesn't form bonds. It's a noble gas, it does not form any bonds. Fluorine and chlorine only form 1 bond. Oxygen and sulfur form 2 bonds. Nitrogen and phosphorus form 3 bonds. Carbon and silicon form 4. All kind of breaks apart here. But boron forms 3 bonds. Aluminium forms 3 bonds, but aluminium we don't normally encounter. The number of valence electrons is the same as the last digit of the group number. So this is group number 1 on the periodic table. It's on the far left, and it's got 1 valence electron. This is group number 19, and it's got 9 valence electrons because it's the last digit of the group number. Oh, sorry, this is group number 17, not 19. It's got 7 valence electrons. Octets. This is your last notes for the video, and this is actually where we're going to stop for today. Please write these down in your books. Atoms want, or they don't want anything because they're little bits of matter, to have a full valence electron shell because it's lower energy. These are electron configurations here, which are the most stable energetically, so the most stable. To get a full valence shell, atoms have to share electrons with each other. Sharing electrons equals forming a covalent bond, which we just represent in chemistry as a straight line. Cool. So on this one, we've got our chlorine and our hydrogen here. What's going to happen is these two single electrons are going to be shared in a covalent bond. So how we're going to draw this is we've got our chlorine here with a single bond to our hydrogen. There we go. That didn't save. There we go. I need a better way of drawing on this. I'll figure it out later. And also, when we do this, let's increase the size. When we do this, we also need to put our lone pairs of electrons in the image. Okay? So we need to put our lone pairs of electrons in. They look like this. Let me just fill it black. And we'll copy paste that a whole bunch. So we've got 3 lone pairs, so 3 pairs meaning 6 total, around this chlorine. There's 2 electrons in the bond between them. Okay, in this bond between them, there's 2 electrons. These 2 are being shared, meaning if we add up around chlorine, we've got 1, 2, 3, 4, 5, 6, 7, 8. Chlorine is happy with 8. It's stable with 8. Hydrogen has got 1, 2. Hydrogen's happy with 2 because it's filled up its outer shell of 2 electrons. Okay? Hydrogen's outer shell happens to only have 2 electrons because it's so small. Okay? Alright, thanks guys for watching the video. I'll see you tomorrow.